Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 8, lesson 6, practice problems. Question number 1. Here's a diagram of an acute triangle and 3 squares. Priya says the area of the large unmarked square is 26 square units because 9 plus 17 equals 26. Do you agree? Well, in our last lesson, we introduced the Pythagorean theorem, which is the sum of the squares of the shorter two sides are equal to the square of the hypotenuse of a right triangle. We emphasize that that only holds true for right triangles, and if this is an acute triangle, that will not hold, so this does not work. Question number 2. M, P, and Z represent the lengths of the 3 sides of this right triangle. Select all the equations that represent the relationship between M, P, and Z. A, M squared plus P squared equals Z squared. That is not the sum of the two legs, the two shorter sides, equaling the sum of equaling the square of the hypotenuse. That does not work. M squared equals P squared plus Z squared. This works. The square of the hypotenuse is equal to the sum of the squares of the shorter two sides. M squared equals Z squared plus P squared. M squared equals Z squared plus P squared. That's the same as the previous one, but with the addition switched around. D, P squared plus M squared. P squared plus M squared equals Z squared. That does not work. Z squared plus P squared equals M squared. Z squared plus P squared equals M squared. That works. It's the sum of the squares of the shorter two sides equal the square of the hypotenuse. F, P squared plus Z squared equals M squared. That also works. Remember, for the Pythagorean theorem, we want the square of the two legs added together equals the square of the hypotenuse, the longest side. Question 3. The lengths of the 3 sides are given for several right triangles. For each, write an equation that expresses the relationship between the lengths of the 3 sides. So, can we just automatically assume these are A, B, and C? No. C is always the hypotenuse, which is always the longest side. So this needs to be 6 squared plus 8 squared equals 10 squared. The hypotenuse, our C, is always the longest side. Square root of 5, square root of 3, square root of 8, which is our longest side, it's this one. The square root of 5 squared plus the square root of 3 squared equals the square root of 8 squared. 5, the square root of 5, and the square root of 30. Which of these side lengths is longest? Well, the square root of 25 is 5, so this has to be our longest side. So 5 squared plus the square root of 5 squared equals the square root of 30 squared. 1, the square root of 37, and 6. Which is our longest side? 6 squared is 36, so this, the square root of 37, has to be our hypotenuse. 1 squared plus 6 squared equals the square root of 37 squared. 3, square root of 2, square root of 7. Which of those is longest? The square root of 9 is 3, so our 3 is the longest side here. So the square root of 2 squared plus the square root of 7 squared equals 3 squared. So we just wrote an a squared plus b squared equals c squared statement for each of these right triangles. Order the following expressions from least to greatest. Okay, we are ordering these from least to greatest. These are all division. So this one is 25 tenths. This one here is 250,000 over 1,000. This one is 2.5 over 1,000. And this one here is 0.025 over 1. Now you'll notice I organize these a little bit, lining up significant digits. 25 divided by 10 is 2.5. You'll notice with this one, because we divided by 10, we moved the decimal point 1 spot. This one here, we're dividing by 1,000, so we can move the decimal point 3 spots. So this one is equal to 250. 2.5 over 1,000. We can move the decimal point on this one 3 spots. And on this one, dividing by 1 doesn't really change things at all. So this one is still equal to 0.025. Now, let's organize this from least to greatest. Which is the smallest of these? This one. Which is the next smallest? This one. Which is the next smallest? 2.5. Which is the next smallest? Or the largest of them, the greatest of them, is 250. So that is these expressions ordered from least to greatest. Which is the best explanation for why the negative square root of 10 is irrational? The negative square root of 10 is irrational because it is not rational. That doesn't tell us anything new. The square root of the negative square root of 10 is irrational because it is less than 0. Nope, irrational numbers can be more or less than 0. the negative square root of 10 is irrational because it is not a whole number. So that's true, an irrational number cannot be a whole number, but it could still be a fraction, so that doesn't tell us enough information. Negative the square root of 10 is irrational because if I put the negative square root of 10 into a calculator, I get negative 3.16227766, which does not make a repeating pattern. An irrational number is a number which never stops and never repeats. So D is the best explanation that we saw. Okay, our next problem here. A teacher tells her students that she is just over 1.5 billion seconds old. Write her age in seconds using scientific notation. Well, let's first write it as a regular number. So, thousands, millions, 1.5 billion seconds. In scientific notation, 1 digit in front of the decimal point times 10 to the power of how many spots did we move the decimal point? 369 spots. 1.5 times 10 to the power of 9. What's a more reasonable unit of measurement for this situation? Well, what do we usually use to measure age? I have a daughter that is 20 months old, but a teacher is probably old enough that we should measure their age in years. How many years is this? If we know how many seconds old it is, how many seconds old they are. Well, if we want to do 1.5 times 10 to the power of 9, now that's seconds. If we wanted to convert it into minutes, we would divide it by 60. There's 60 seconds in a minute, right? Dividing it by 60 is the same as multiplying by 1 over 60. Okay. That would tell us how many minutes old they are. To find out how many hours old they are, we would divide it by 60 or multiply by 1/60th again. If we wanted to find out how many days old they are, we would divide by 24 or multiply by 1/24. That's how many days old they are. Now, if we wanted to know how many years they are, there are 365 and a quarter days in a year on average, taking in leap days. So that will tell us how many years old they are. So let's rewrite this first. We can combine all of those and combine that. That would be over 1. So if we combine all of these, we would have 1.5 times 10 to the power of 9. And then we could just multiply all of those through, and that would be our new denominator, which would be 31,557,600, or about 3.16 times 10 to the power of 7. So now we would have to do 1.5 divided by 3.16, which is 0.47, times 10 to the power of 9 subtract 7 is 2. So the teacher's 0.47 times 10 to the power of 2 years old. Well, now maybe the scientific notation doesn't make quite so much sense anymore. 0.47 times 10 to the power of 2 is 47. The teacher is 47 years old. This has been another episode of Mr. Boskin Does Some Math. Thank you very much for tuning in. See you next time.